Hi, Assalamualaikum and a very good day to everyone. My name is Muhammad Ammar Anuha bin Sabri from Group 15 and will be presenting on the torsion on plastic bottle for KIB2003 Mechanics of Material. Do you know, in our daily life, we use torsion in the prep work to recycle plastic bottle. Our group is interested to find out the mechanics of material for this action. So, let's get into it. For the parameters needed for the calculation, we need to measure the dimension of the bottle. So by using a measuring tape and also a ruler, we will measure the height of the bottle and the diameter of the water bottle. And then after applying the torsion, we can calculate the twist angle by using this line and measure the difference between the top line and the bottom line. From the measurement, we get the height of the bottle and the diameter of the water bottle. Because of the water bottle is in irregular shape, so we assume the water bottle as a hollow shaft. So this is the simplified figure of the water bottle. And because we don't have the access to the equipment to measure the shear modulus, we turn to internet to find the shear modulus of the plastic bottle, which is polyethylene terephthalate. So this is the value, and from there we get all the parameters needed for the calculation.
Hi, my name is Abdul Hakim bin Abdul Rahim. Okay, today I will be presenting the case number 1, which is the twisting of plastic bottle. So this is the real plastic bottle, which is cactus bottle. So we just get the 0.3 meter of bottle after we cut the upper part of the bottle because the bottle is in irregular shape. So we'll twist this part of the bottle. And then the diameter of the bottle is 0.08 meter. Okay. We move on to the next part. So, in this case, we will try to measure the torsion of the plastic bottle that been twisted. So, before that, we will find the value of J, which is represented for polar motion of inertia, which is this is the formula, which we must get the C2 and C1. So the C2 is the outer radius, which is equal to 0.04 meter. And then for inner radius, we will get by subtracting the C2 with the thickness of the water bottle. So we will get 0.03622 meter. So we'll get the J equal to 1.324 to the power of -6. And then to get the torque, so we will just use the formula of angle of twist that we get the value of angle of twist equal to 72 degree or 1.257 radian. So we'll just plug in the values of the value of angle of twist, and then the height, which is 0.23 meter, and then the J that we get just now, 1.324 to the power of -6, and the G, which is the shear modulus, equal to 3378.43107 megapascal. And then we get the T equal to 24.446 kilonewton meter. So that's all to get the torsion for the plastic bottle. So I will pass to the next member. Thank you.
Hi, my name is Zohai, and now I will continue presenting about the calculation of shear stress of the bottle. So the shear stress is produced on the faces perpendicular to the axis, when the torque applied to the shaft. The condition of equilibrium required the existence of the equal stresses on the faces of the two planes containing the axis of the shaft. The existence of the axial shear components is demonstrated by considering a shaft made up of axial slots. The slots slide with respect to each other when the equal opposite torques are applied to the ends of the shaft. The bottle is in hollow shaft structure. So we can calculate the shear stress like this. The torque is 24.446 kilonewton meter, and the C we can get the value by subtracting the outer radius with the inner radius. Then we get 3.81 times 10 to the power of negative 3 meter. Then the J, which is the polar motion of inertia, which is 1.324 times 10 to the power of negative 6 meter per square, like Hakim calculated just now. So now we can calculate the shear stress by multiply the T and C and divide it by J, and we get 70.347 times 10 to the power of 6 Pascal, which is equivalent to the 70.347 megapascal.
Hello, my name is Hakim Yunus, metric number KIB2003. So today I will show to you one of the application that can be related to the twisted bottle. So we choose Pylon. Pylon is one of the part at the prosthetic leg, this one. So the height we choose is 180 millimeter. So for the cross-sectional, we choose the diameter we choose is 0.032 meter. From this, we can get the cross-sectional area equal to 8.0425 times 10 to the power negative 4 meter square. For the pylon, the max weight we choose, max weight that can hold is 100 kilogram. So we change it into the force. So for the ultimate stress, we can get by using the formula force over cross-sectional area. So which is a force we get here over the cross-sectional area. So then we get 1.220 for 1220 megapascal. Next, we move on to the allowable stress. So allowable stress, we choose a body weight of person 80 kilogram. Because of one leg, so we have to divide into 2. So we get 400 kilogram. So the force is 392.4 Newton. So use the same cross-sectional area. So the allowable stress equal to same formula, force over cross-sectional area. So then we got 0.488 megapascal. Lastly is the factor of the safety. So the formula for the factor of safety is ultimate stress over allowable stress. So we got the both ultimate and the allowable, which is 1.22 over 0.488. Then we get the factor of safety equal to 2.5.
The application of our case study, we find out that uh, in the making of the best prosthetic, transtibial prosthetic, pylon was the major part. This is because pylon will must have the strength and must have the longevity. This is because pylon will have always under pressure, especially while the patient was walking. So one of the material that we find out having the stress, having the strength that can make it last longer and provide safety for the user is uh, metals such as stainless steel and aluminium. However, this uh, material consists such high weight. So means this material will provide the user discomfort, so the user might not wear our product, which is the transtibial prosthetic. So one of the material that we think was the most suitable is carbon fiber. However, carbon fiber have a slightly less strength rather than a stainless steel and other type of material like metal aluminium. However, we can increase the strength uh, uh, by reducing the inner diameter and increasing outer diameter. So, by having the increase in outer and decrease in inner diameter, the strength, the axial strength, and the shear strength can be increased. Okay, so and plus the carbon fiber have the weight
reduced, can have the weight reduced. Therefore, the comfort of for the user can be increased. Okay, that's all for the application of our case study. Therefore, thank you.
たらいいなの妄想と現実に一石を閉じて個性を磨け結界悩むなんだよまた一つ消去頭からケツまでそれが我がエンタメだ